Number 4, Mabry wanted to measure the height of her school's flagpole. She placed a mirror on the ground 24 feet from the flagpole and then walked backwards until she was able to see the top of the pole in the mirror. Her eyes were 5 feet above the ground and she was 8 feet from the mirror. Using similar triangles, find the height of the flagpole to the nearest hundredth of a foot. All right, so to set this up, again, we have similar triangles. These angles right here are congruent to each other, so these two sides correspond, and the person's height to his eyeballs corresponds to the height of the flagpole. So we can do the actual height to the distance to the mirror. So we can say 5/8 equals the actual height over the distance to the mirror, which is 8/24. We could have said, use the distance over the mirror, and the distance from the mirror, and said 8/24 equals the actual height, which would be 5/8. No matter how you set it up, what you'll notice is that the 5 and the 24 are diagonal from each other, and the 8 and the h are diagonal. So there's many ways that we could have done this, and of course we could have done the reciprocal of both of these. All right, so to solve this, we're just going to cross multiply. So 8h equals 120, and then we divide both sides by 8. And so h is 15. Again, this is a real life problem, so we got to make sure we put units, and we're talking about feet. And it makes sense. The person's height is less than the distance they are from the mirror. So the height of the flagpole should be less than 24, and it's 15.